Hi, I'm Dr. Incognito. In this video, I'm going to discuss the Intermediate Value Theorem. The Intermediate Value Theorem. So this is a theorem that applies to continuous functions. So it's very important that the function that we deal with in this theorem is continuous. If the function is not continuous, then the conclusions that we reach may be false, in fact. So suppose that f of x is a continuous function on some closed interval from a to b. And furthermore, suppose that I is an intermediate value for the function. I is an intermediate value. What that means is that I is between the values for f of a and f of b. So the function takes on the values f of a and f of b at the endpoints of this interval, and I is some number in between. It's an intermediate value. Think of something like temperature. If the low temperature is 40 degrees one day and the high temperature is 65, then 50 degrees would be an intermediate temperature, somewhere between 40 and 65, intermediate. So f of x is continuous on the interval from a to b, and I is an intermediate value. Then the conclusion is that there exists an input to the function somewhere between a and b, such that f of that input is exactly this intermediate value. So then there exists a number x0, I'll call it, between x equals a, the left end of the interval, and x equals b, the right end of the interval, such that f of x0 is equal to the intermediate value. So a continuous function takes on all of its intermediate values over an interval. The picture associated with this, let's say this is a, and let's say this height here is f of a, and let's say this is b, and let's put f of b down here, f of b, and let's put I somewhere in between f of a and f of b, an intermediate value. Then if we draw a horizontal line at the height I over the interval from a to b, so a horizontal line like that at the height I, then what this theorem is saying is that if you draw a continuous function that connects these 2 points, a comma f of a, and b comma f of b, if you draw a continuous curve that connects these 2 points, then it must intersect this horizontal line. There is no way to avoid that with the graph of a function. Remember that a function graph passes the vertical line test. So there is, if we drop down to the x-axis, this is the value x0 guaranteed to exist somewhere between a and b, such that f of x0 is equal to I. So this is the theoretical statement of the theorem, and here's the associated diagram. And now an application to polynomial equations. Suppose we take the equation x to the 5th minus 3x squared plus 2x minus 4 equals 0. Suppose we wanted to solve this equation. Well, finding an exact solution might be very difficult, maybe even impossible. But one thing I can say from the intermediate value theorem is that this equation does have a solution between x equals 1 and x equals 2. Because I did a little bit of work earlier to discover that if I plug 1 into this function, then I will get a negative number, and if I plug 2 into this function, I will get a positive number. And so my upper value here will be positive, my lower value actually will be negative, and therefore somewhere the curve will have to cross the x-axis, and therefore the height of the function will be 0. So I'm going to begin by saying let f of x equal x to the 5th minus 3x squared plus 2x minus 4. This function is a polynomial, and so that implies that it is continuous on any interval. It's continuous on any interval. It's continuous on the interval minus infinity to infinity. So it's going to be continuous on any interval from a to b. So I can apply the intermediate value theorem to a polynomial on any interval. Furthermore, let me notice that, so let's note that f of 1, what is f of 1? If we plug 1 in for x, we get 1 minus 3 plus 2 minus 4. So that is negative 4, which obviously is less than 0. And let's calculate f of 2. F of 2 is 2 to the 5th is 32 minus, this is 4 times 3 is 12, plus 4 minus 4. So this is 20, which is definitely positive. So f of 1 was negative, f of 2 was positive. I want to show that this equation has a solution, so I want the function to equal 0. So let's notice that 0 is an intermediate value. 0 is between, 0 is playing the role here of I. It's going to be the intermediate value. 0 is between f of 1, which was negative, less than 0, and f of 2, which was 20, that's greater than 0. So 0 is the intermediate value between f of 1 and f of 2. So now by the intermediate value theorem, since f is continuous, by the intermediate value theorem, there is a number x0 between x equals 1 and x equals 2, such that f of x0 will equal 0, my intermediate value. There must be an x0 between a and b, between 1 and 2, such that f of x0 equals my intermediate value, which in this example is 0. So that shows that this equation has a solution somewhere between x equals 1 and x equals 2. So when x is 1, the function was negative. When x was 2, it's positive. Those are not solutions themselves. But since one of them was negative and the other one was positive, there must be a solution. This function must equal 0 somewhere between x equals 1 and x equals 2. That's an application of the intermediate value theorem. And let's just draw a quick, the sketch in relation to this particular example. Another sketch like the one I'm erasing, but for this particular example, it's showing that when x is 1, f of x is negative 4, which I'll just put here. And when x is 2, f of x is 20, so let's just say 20 is there. Scale's a little off. But the function, the polynomial function, f of x, the polynomial, so if I draw y equals f of x, that's a continuous function. It's going to connect this point here at 1 comma negative 4 with this point here at 2 comma 20. If I draw any vertical line, horizontal, line between a height negative 4 and 20, then it has to, the curve would have to cross that line. In particular, I'm going to draw it at height 0, because the number on the right side here is 0. So somewhere this curve has to cross the horizontal line here on the x-axis between x equals 1 and x equals 2. So that's the value x0. I don't know exactly where it is, but I know it's somewhere between 1 and 2 for sure. Okay, so that's an application of the intermediate value theorem. Thank you for watching.